Cooling's been around for a long time, 10 years, 12 years, more. Supercomputers have been doing it for a long time. And everybody's talked about it, when's it going to happen, when's it going to go mainstream. And I've been in data center business for 20 years, and everybody asks the question every year. And it's mainstream now. It's mainstream now. Direct-to-chip is taking over data center construction in the United States, and huge demand, huge supply chain stresses, huge human resources stresses. So super important topic. Glad that you're here to listen today. So the typical picture here of an AI data center, liquid-cooled racks. I'd like to say most people have seen the outside of a cold plate, but they've not seen the inside of a cold plate. So why is fluid quality important? Well, there are things that can go wrong, okay? So we've done a lot of work with supercomputer companies and fluids, and a lot of times they'll have a problem. Hey, can you come in and help us solve the problem? We've got a problem with chips. We've got a problem with not getting enough heat transfer. And so there are multiple things that can happen. You can have fouling with suspended solids. You can have fouling with scale. You can have corrosion issues on the cold plates, inside the cold plates. But one of the biggest topics that everybody is concerned about when it comes to especially a water-based solution is biofilm, okay? You know, a lot of people wonder, why doesn't everybody just use water? Why are you using glycol? You know, what's so important? You know, water makes more sense mechanically, energy efficiency-wise. Well, the main reason is biofilm. You know, you only see a few players in the hyperscale place that are using water-based solutions right now. Most of them are using glycol, and the main reason is they're afraid of biofilm. Biofilm causes a lot of problems in cold plates. These gaps here that you see, these are magnified pictures. But the distance between these is typically 75 to 100 microns. So if you feel a strand of your hair, one hair is roughly 75 to 100 microns wide, which means one hair gets between those channels, and now you don't have flow. So that's how serious this concern is, and why you really need to be concerned about coolant health, and are you monitoring it, or are you taking care of it in the cooling system? So like I mentioned, we've done a lot of work with glycol, and one of the things we've noticed is that glycol can change over time. There's several parameters that are important for monitoring glycol. pH, conductivity, turbidity, these are pretty common, but percent glycol is especially important. You need to know, are you maintaining the right percentage of glycol in the system? If it degrades over time, what's going to happen is glycol at 25% is normally biostatic, means it will prevent the growth of microbiological organisms. But if you get too far below the 25% concentration, it actually will become a food where you can grow microbiological organisms. We have a lot of detail, a lot of research we put into this. So we went through some of our historical analysis of glycol systems to see what do they typically look like. Are there parameters that normally what might get out of range that would be a concern? And we found that out of a lot of these samples, almost 80% had one parameter out of spec. It could have been pH, could have been reserve alkalinity, right? It could have been the percent glycol, but we found actually a very surprising number of samples that had glycol out of range after a period of time. So with this, we figure it's really wise to know how are you going to monitor and take care of the glycol if you run into a problem. How are you going to prevent the cold plates from becoming fouled? What are you going to do if you have an alarm and something happens? And to do this, well, you have to do monitoring. There's no other way around it. So this is a very interesting analysis that some folks on our team put together. Because, you know, why is this important, right? Well, we all know what's driving everything. Everything is AI. It's the chips. This is what's driving everything. So our team worked with some of our customers to say, well, what is the potential revenue loss? What does it look like if I get biofilm and now my chips are overheating and I have to shut a system down because I need to clean it? What would be the issue or revenue-wise that could impact? And so what you see here is on the left is an example for GB200 chips. On the right is an example for H100 NVIDIA chips. When you look at this, and I'm not going to go through every single line here, but what we did was we did an analysis based off of a 96 megawatt data center with 8 modules within that 96 megawatts. So per module, the lost revenue, if you had to go and take this offline for 10 hours, For GB200 system, $476,000. For an H100, $90,000. And these is what our hyperscaler customers are telling us, like, this is real lost revenue for them. So the issue with coolant health and coolant quality has become super important in these direct-to-chip systems. And again, it all goes back to the cold plate cooling the chip directly. Now, here's the thing. You get a system, and now it has downtime. Are you going to be able to recover that system within 10 hours? The likelihood is no, because you're going to need a team of people to come in. Okay, what are we going to do? What's the remediation process? How are we going to take care of this? You're going to look at more like 5 days until you get this whole system resolved and taken care of. So you take that number now, and you figure 5 days, you're in the millions of dollars of cost when it comes to lost revenue for downtime. So we think this is just a really helpful way to look at this. It really stresses the importance of the coolant quality. So in May of last year, Nalco Ecolab, we've been in water and fluids monitoring, testing, analyzing for over 100 years. This is a very core strength of ours. We do it all over the world. We're in 170 countries. This is a very core strength of what we do. So we developed an online glycol monitoring skid. Now, we can get this as a standalone solution. We actually have this as an option too that can be put within CDUs. So you can get a CDU pre-built with the monitoring solution here. And so key things that we're monitoring, percent glycol. Key factor, right? Because we see that over time, it's not surprising to see percent glycol go down. Sometimes we see an issue in the construction process. Sometimes when you do the final rinse of a direct-to-chip system, we've seen this in the United States where either the design or the construction, not everything is drained. And so let's say you're going to fill a system with a 25% propylene glycol, like an LC25. And so you do your final rinse, you do the drain, you fill it with LC25, you begin to circulate it, and all of a sudden you realize, uh-oh, I have LC20. I have 20% propylene glycol. I don't have 25%. Now I'm in a danger zone. Now I have to figure out, okay, how am I going to solve this problem? So the design and the engineering up front is super important to make sure that you don't run into a problem later on with the construction process. We've seen this on projects. We literally in different data centers in the United States. It's not every project. It's not half. It's not, but it's enough that what it does is it creates headaches and it creates delays. And if you are a data center operator and you have a contract with a hyperscaler, you know the cost of delays. The hyperscalers expect you to finish the project promptly on a certain date. And if it's delayed past that, there are often penalties for that. So this is why the planning and the monitoring and the construction, our philosophy is design clean, construct clean, operate clean. And we walk it through that whole process. I'm going to call out one other item in here that we have, right? We have the pH turbidity connectivity, but we have very high quality sensors. You know, in the water treatment industry, you can get something really cheap, you can get something really expensive. When you have something really cheap, what happens? The sensors fail, they have to be calibrated. So let me ask you, if you use cheap sensors, do you really want a technician going in once a month to calibrate and change sensors? Most people that I know in data centers are like, I don't want all that extra hassle. I want something that's a high quality for this. The sensors that we use go a year, they don't need to be calibrated, they don't need to be replaced. We have a very high quality sensor package. We think this is really important for this application. We do have a differential pressure sensor in there, and what that's in, it's not actually, it has a small filter there. It's not to filter the system, but it's to record a significant change in differential pressure from contamination. So one of the risks down the road when you're in the operational stage, what if you replace racks? What if you replace servers, but do you know that they're really clean? We have a process that we've come up with in our cooling as a service program where we'll do cleaning and pre-cleaning and verification and quality control of the fluid that's in the server or the rack. So when it's replaced, it's been documented this is clean and compatible with the existing system. There are places where we've seen it be replaced, and all of a sudden now the system's been contaminated with suspended solids. The differential pressure shoots up, and it's like, uh-oh, you just added something onto that loop that contaminated that loop. So quality control in this entire process, super important. All right. So just kind of give an overview of what we are supporting in the data center industry from what we call cooling as a service. CDUs, we have CDUs now. We also are currently working on an acquisition that should be closed in Q3, where we have thousands of CDUs installed in the marketplace in data centers. Real-time data, we'll do real-time monitoring for the sensor suites and the things that gather this data and information where we can do troubleshooting and proactive support for customers. The coolant suite, so we have multiple types of coolant solutions. There are some chips that what we've seen is they don't want to use glycol, they want to use water. We have a water-based solution for the folks that want to go that route. And then the service and technical expertise. Ecolab, we have almost 50,000 people around the globe, and most of these people are people who actually go in and support customer sites, customer projects. So we have a huge fleet of people, and especially here in India, we do a lot of managed operations and supports across multiple industries in India. So we have a very strong local team and data center support team in India. And that's it. Thank you very much for your time.